Hello, everyone. Ever wondered how the incredible AI systems we use daily, from Netflix recommendations to ChatGPT, actually think and process information? Today, you'll uncover the fundamental building blocks, the secret language that powers all of that, matrices and matrix operations. We're leveling up from yesterday's vectors to these powerful rectangular grids of numbers. By the end of this lesson, you'll not only be able to create and manipulate matrices using Python to represent real AI data, but you'll also deeply understand how every image, every vast dataset, and every complex neural network fundamentally relies on these mathematical structures. We'll even get hands-on by building a simple image brightness filter using matrix operations, giving you your very first taste of computer vision. This lesson is designed to transform you from someone who simply uses AI into someone who truly grasps the mathematical foundation that makes all modern AI possible. Let's dive in. Yesterday, we explored vectors, single rows or columns of numbers that are great for simple lists. But today, we're leveling up to matrices, these incredible rectangular grids of numbers that power everything from Netflix recommendations to self-driving cars. Think of a matrix like a sophisticated multi-dimensional spreadsheet. But instead of just storing budget data, matrices hold the fundamental building blocks of intelligence itself. Imagine a black and white image. It becomes a matrix where each number represents a pixel's brightness. Or consider the brain of a neural network. It's actually a vast collection of matrices storing all the learned patterns and connections. When ChatGPT processes your question, it's performing millions of matrix operations every second. The beauty of matrices in AI lies in their dual nature. They're both powerful mathematical objects we can calculate with and meaningful representations of complex, real-world data. This combination is what makes every AI breakthrough possible. Now that we've grasped what matrices are and why they're so essential, let's look at how we actually build them in a practical setting, especially using Python's powerful NumPy is NumPy library. Creating matrices in Python feels quite natural once you understand the pattern, almost like building with Lego blocks. You'll use functions like np.zeros to initialize neural network weights, np.I to create identity matrices crucial for transformations in computer vision, or np.rand.rand to generate random starting weights for machine learning algorithms. Each of these serves a distinct purpose in an AI system. Crucially, every matrix has a shape, its dimensions, that tell you exactly how the data is organized, like a 3x4 matrix having 3 rows and 4 columns. In AI, this shape matters enormously. A neural network layer expecting 1,000 inputs simply won't function correctly if you feed it a matrix with a shape of 500,2. Understanding and correctly managing matrix shape is a foundational skill for any AI developer. All right, you've created your matrices, filled them with data, but how do you actually look inside them? Navigating through matrices is like having a precise GPS system for your data. You need to be able to access specific elements, entire rows, or even whole columns to truly understand what your AI system has learned or to modify its behavior. Using Python, it's straightforward. Image matrix 0, 0 gives you the top left pixel. Image matrix 0, colon grabs all pixels in the top row, and image matrix 2 accesses all pixels in the middle column. This kind of precise indexing and slicing becomes absolutely crucial in real-world AI development. For instance, if your AI model isn't recognizing a specific feature in an image, you might index into a feature matrix to see how that feature is represented. Or if you're analyzing learned patterns, you'll slice out specific weight matrices from your neural network to examine them. It's your window into the AI's internal workings. Finally, we arrive at where the real AI magic happens: basic matrix operations. This is where static data transforms into dynamic, intelligent behavior. Simple operations like adding matrices allow you to combine different data sources, perhaps merging environmental sensor data with historical records. Multiplying a matrix by a scalar lets you easily adjust values across the board. Think of it as increasing the brightness of an entire image or amplifying specific signals in an audio input. These seemingly simple operations, when chained together and repeated millions of times per second, are what enable complex, intelligent behavior. For instance, when Instagram applies a sophisticated filter to your photo, it's executing a series of matrix operations. When a neural network accurately recognizes your voice or detects an object in a video, it's continuously transforming audio or video matrices through dozens, if not hundreds, of these mathematical steps. These fundamental operations are truly the bedrock upon which all advanced AI systems are built.